This brings us to the next pillar of the Citrix platform, which is scalable compute. As we now have these millions of new mobile applications that are coming out into the marketplace, they need somewhere to run. All of these mobile apps need a back end. And this back end needs a platform that can run these new application architectures. And enterprise IT needs a platform that they can use to burst out to deliver efficient, cost-effective compute workloads. So to talk through the scalable compute problem and how we solve that, I'd like to welcome our next two presenters, Sheng Liang, who's the CTO from our Cloud Platforms Group, and also a very special welcome, a guest today, Phil Harris from CTO, who is the CTO from Cloud Services and Management at Cisco. Please welcome Sheng and Phil.
Thank you. Thank you.
Thanks, Martin.
Thank you, Phil, for coming to the stage with me. Before Phil gets into talk about how Cisco and Citrix are going to work together to solve the cloud scalability problem, I'm just going to give a little bit more background about where this problem came from. So as Martin said earlier, the scalability problem really fundamentally came from the growth of mobile devices and mobile applications. Every mobile application you have on the phone will end up making a connection back to the data center in the cloud somewhere, and it will invoke some code. So a mobile application really consists of two parts. The first part of the mobile application sits on the phone, or a laptop, or a tablet. The second part of the mobile application sits in the cloud. And when we talk about cloud scalability, we're talking about the fact that we have to scale the ability for cloud to serve a lot of concurrent mobile sessions as the adoption of mobile application grows. So what does a mobile app look like when it exists in the data center? Quite likely, it runs on a virtual machine somewhere. And since this virtual machine serves requests from the internet, we probably need a firewall. And as traffic grows, we probably need more than one virtual machine. And as a result, we'll put in a load balancer or application delivery controller. And unless we're just doing a very simple website that does not have any complicated business logic in it, more than likely, we'll need a multi-tier app. We probably need an app tier. We probably need a database tier. Now, a lot of these applications also don't stand by themselves. Many of the applications need to access your legacy data source that's locked away somewhere inside the enterprise. So we probably need to open a secure VPN tunnel from your cloud data center all the way back to your legacy infrastructure. So this is what a typical mobile app looks like in the cloud. And the challenge of scaling this mobile app is really all about how do you take something like this and you fit it into a cloud hardware, physical server, network infrastructure, data center. And this picture shows what a typical cloud data center looks like. It basically consists of a fairly scalable network infrastructure and racks of servers. Now, a lot of our customers actually have architectures that look very similar to this. Cloud service providers such as BT, KT, you walk into their data centers, that's basically what you see. And because these cloud service providers serve enterprise, typically they enable the enterprise to create a secure tunnel between the public cloud data center and the private cloud intranet. And the tunnel could be supported by a VPN or by Citrix Cloud Bridge. So I'm coming back to the problem is, how do we take the type of topology, that network topology that we described, and fit it into a physical server and networking-based data center, as I show on this slide. And one big part of the solution is server virtualization. Virtualization, as implemented by Citrix Zen Server, is extremely mature and extremely wide accepted by now. It is the foundation for cloud infrastructure. But the big challenge today is actually no longer server virtualization. It is network virtualization. How do you take an arbitrary application level network topology like this and make it fit? How do you make many, many instances of those application topologies fit? So really, there's nobody better suited to explain the concept and the promise of network virtualization than our expert from Cisco. Phil?
Thank you, Sheng. Good morning, ladies and gentlemen. I'd like to also thank Martin and Sheng for inviting me this morning to present with the rest of the CTO group from Citrix. Just before I get into the details, I just want to say one thing. I've been working at Cisco for a long time, and in a lot of the time I've worked there, working with various partners, I can honestly say I've never worked with a partner where we've got so much done so quickly with so much synergy between the groups. No pun intended with the conference today. But the rapid adoption of how our thinking has pervasively grown throughout the organizations is quite remarkable. So what I'm going to do this morning, I'm going to do a little bit of a history discussion, how we got here, and then talk about what we're doing. And we've got a multi-phased approach here, and we're going to talk about some of those phases this morning, but this is a long, planned execution roadmap we have. But let's start off by thinking about how we got here. Data centers in the past have had very rigid constraints in terms of containing the operational and performance envelopes that we need for the workloads and the applications that run within them. And very much we can think of the static nature of these data center configurations to be based on the fact that we had to do most of the provisioning manually. We had to think about scaling in a very limited fashion, and quite frankly, because we wired once. You don't go back into your data center and start moving RJ45 cables around if you want to keep your job for very long. You can do it, it just doesn't work very well. So we build these things, these large-scale data centers, but they're limited. And the mobility of workloads, which is one of the real promises of virtualization, it's great that we can, I call it the Tetris game of VM packing, where we really optimize the use of our servers by playing these games like Tetris, where we have all these different size and shaped VMs that we cram into these servers. That's great, but we also now have to think about mobility. So what can we do to take what we have today, scale it, provide elasticity and fluidity, and enable us to get more policy-based configuration provisioning? So the way we have to do this is, first of all, to think about the fact that we need to instantiate service nodes or service capabilities pretty much in real time. Whether it be user-driven data centers that are having workloads provided by the consumer or the subscriber that are instantiated in real time, where they want a load balancer or a firewall or some form of site-to-site VPN termination. We need to establish these service nodes in near real time or at the same time the VMs are instantiated. That's going to be done by policy. And we can't think about the old kind of ships in the night architectures where the data center was a bunch of bumps in the road in the network with a bunch of servers that were really almost orthogonal to the thinking from a networking perspective. We've heard all about SDN, software-defined networks. This isn't new. It sounds new because we're all talking about it right now, but this isn't new. Cisco released something called the Nexus 1000V about 3.5, 4 years ago, around the same time we launched the UCS platform. And this was the first time we really had a software-oriented switch where we decoupled the control plane, where we apply policy, and the forwarding plane, where the actual work of moving traffic occurs. This is an incredibly important premise, because now we have the ability to have multiple of these virtualized switch infrastructures across the data center, where centralized controllers, that centralized abstracted control plane, can apply policy in multiple parts of the data center. So now as VMs get instantiated in real time in different parts of the data center, or they move between locations in the data center, we can move that policy with it. This becomes important because now we can start thinking about a more fluid environment. But still, we've got to go one step further. Because now we've got policy-based provisioning, that's great. We can scale to more abstracted limits than the physical wiring we had before. And now we can get to data center-wide mobility and instantiation of fluid VMs. But we've got to go one step further, because the real promise here is automation. Automation that allows us to set models of how our data centers can be described, or the features and capabilities of these data centers can be described, and then instantiate those models so that users can pull a model out of a self-service catalog, and the infrastructure will build around that requirement. Now, to do this, we have to integrate various layers of the stack. And this is really the interesting work that I think you're going to see us describe this morning, and going forward, the real jewel in the work we're doing between Cisco and Citrix. Because I think now we can look at how we can take the cloud infrastructure that allows this self-service, user-centric experience and have complete integration of all the various control points and control services throughout the stack. Now, this really wasn't doable before, because most of the networking gear was, quite frankly, arcane, command line interface-driven types of infrastructure that didn't lend itself well to these very dynamic environments. So what we're going to talk about, and we're actually going to have a demonstration, which we'll talk about in a few moments, but we're going to look at an implementation that we've done between the two teams, where we're applying some of the existing Nexus 1KV technology we've mentioned before, with some very, very specific capabilities which is unique to this platform. vPath I'll talk about very quickly in a moment. But let's look on the left-hand side of this slide. We have a number of service nodes. Let's not think of them as appliances. Let's think of them as service nodes. And these service nodes are policy-driven in terms of being configured and instantiated in real time in these tenant containers where we now abstract our data centers. The ability to then have these dynamic service nodes pinned together around certain flows of traffic that we can identify because they're between that web server tier and the app tier, or the app tier and the database tier. And we can apply the right service nodes to these. This allows a great deal of flexibility. And also then be able to continue that through the wide area network, so we can have complete transparency as VMs move across data center locations or between different clouds. Now, as Mark said yesterday, if we poll the people in this room, everyone's data centers are going to look somewhat different. But there will be some similarities. Now we can get to the situation where every data center is a function of the policy around the workloads. And this is a critical change in how we do networking in this virtualized environment. So one of the things I want to talk about is the fact, now, by the way, in real life, we might see many more of these service nodes and configurations. But let's look at what we're going to talk about today. We're going to talk about how the Nexus 1KV provides the segmentation of these various tiers of the multi-tiered app environment, how it instantiates the pinning or the connections between these various tiers and load balancers. Now, the load balancer, this is interesting. Do we always want load balancers? When we hit a scale, yes. But what about making sure that we can calibrate so we scale the number of load balancers? We saw how we can have multi-tenant load balancers before. We saw how we can scale those in real time. We want to be able to do that based on policy. And that's why NetScaler is such an interesting technology and exciting technology for us to integrate into our architecture, because now we can see how in real time we map the load and the load balancers to the policy. How we provide firewall capabilities in real time, and then how we can connect between data centers. So what we're going to do now is provide a short demo where we're actually going to show how we look at the old way of doing this with somewhat arcane command line interfaces, but then how we start using these APIs that I've been describing to do this in a more programmatic way and a more automated way. So Chiradeep.
Hi, thanks, Phil. So Chiradeep was one of the original founding engineers at Cloud.com, and he's also the architect behind a lot of the networking capabilities in Citrix Cloud Platform. So the first thing we're going to show is, as Phil said, Cisco has an industry-leading SDN product. It's called Nexus 1000V. It's a very powerful switch, but it's all implemented in software. And the way you access a software switch is exactly like you access a hardware switch. So Chiradeep here is logged into the switch.
Yeah, so if you wanted to do some of the stuff that you and Phil were talking about, dynamically instantiating networks, if you were a network admin, a Cisco admin, you would have to go into the command line interface like this and then type in commands like the one shown here. And just a simple configuration like that one could be easily hundreds of lines. not easy to do, and quite error-prone.
Yeah, so this is exactly what Phil meant when he said the stage 1, which is everything's manual. It is software-defined, but what's nice is the state-of-the-art Cisco Virtual Network Management Center. They've started to integrate with the API control that's available from these underlying network infrastructure. And now, deep logging and perform some actions through the GUI.
So the VNMC is a very nice interface to do the policy-based provisioning, which Phil was talking about. And here you can see that I've defined the data center like you had, the virtual data center with the app tier, the web tier, and the database tier. And I've also managed to associate a virtual firewall, the Cisco ASA 1000V, to this data center, and then apply policies on it to this virtual network management console.
This is fantastic. I mean, this application is just simply, it's beautiful. But more importantly, it enables data center administrator, the network administrator, to be able to configure data center networking, virtualized networking, without actually running, having to do command lines. He's able to define policies and apply it to a large set of physical and virtual network infrastructure.
That's right, a huge improvement over the command line interface.
What's lacking, though, this is still, at the end of the day, an administrator tool. So what it doesn't support is it does not support self-service. It does not support a very high degree of automation for the set of tasks that an end user might want to do, that a consumer of an infrastructure as a service want to do. So for that, we're going to show some of the latest integration actually Shirdeep did to integrate the API into Nexus 1000V and Cisco Virtual Networking Management Center, VNMC, with Citrix Cloud Platform built on Apache Cloud Stack technology.
That's right. So here I'm logging into our cloud in California. And what you can see is I already have a few VMs running. And I'll show you the container which Phil and Sheng were talking about.
So he's selecting what's called a VPC, a virtual private cloud, which is an isolated network environment that sits in a cloud. So it's by design, it is multi-tenant enabled.
That's right. So we talked about having a multi-tier application. Here I already defined a database tier and a web tier. Now let me just add a new tier. Let's call it the app tier. And
so it only really took a few types and a few clicks to get a network created. And what's happening behind the back is actually quite magical. We're reaching out to Cisco VNMC and Nexus 1000V control the software-defined network infrastructure and get very sophisticated network topology created for this particular application.
Yeah, and at the same time, you can control your compute. So let me go ahead and add a virtual machine to this tier. And while that's happening, now I want to be able to define security rules saying that the web VMs can access the database or the app VMs on the app VM port. So let me go ahead and configure the ACLs for that.
Yeah, because we have integrated firewall, so it's very easy to say, I want to expose the web tier to the internet, but I certainly don't want to expose the app tier and database tier to the internet, but I do want to expose the app tier to my web tier.
So the apps typically listen on TCP port 8080. And there you have it. Now the web VMs can talk to the app VMs.
It's that easy. Just again, with a few simple types and clicks, we get we get an access control rule set up without ever have to touch the command line. And this is the type of interface that a self-service infrastructure service consumer is actually able to use.
And the second thing that you and Phil talked about was the load balancer. And the Cloud Stack gives you access to the load balancer as well. And here we can configure load balancer to the web tier. So let's call it My Mobile App.
So what Shirdeep's trying to do here is he's actually configuring a NetScaler VPX instance that we're going to specifically create for this application. Again, it only takes a few clicks, and it's fully automatic and fully self-service.
That's right. And then with NetScaler auto-scaling technology, you can even scale the web VMs automatically.
Now, one last thing, we're going to create a site-to-site VPN back to
That's right.
the corporate data center.
We talked about doing a site-to-site VPN. And here I'm going to define a new IPsec connection back to the Citrix headquarters. And I'm going to avoid clicking on that because it might get me in trouble with IT, but there you have it. All point and click. And the neat thing is that you can use APIs to do the exact same thing and get rid of the UI as well.
Thank you. Thank you very much.
Thank you.
Phil?
Thanks, Shirdeep. So what we saw there was a very good example of how we can drive everything from a self-service selection portal in terms of configuring the infrastructure all the way through the service chain creation, all the way through the configuration of those segments, firewalls, load balancers, and making this not only simpler, but quite frankly, less error-prone, more fluid, more dynamic, and faster. And this was by utilizing parts of Cisco's intelligent automation suite and the APIs directly integrated into Cloud Platform. Now, Padma yesterday at the keynote, for those of you at the keynote, mentioned the Cisco Open Networking environment. This is how Cisco is moving to a fully programmatic interface definition of all of our various capabilities from a product perspective or a controller. What is a controller? Let me just talk about that for a second. Controllers are important. We're going to see this a lot more in the industry. This is where we've moved state from traditional devices into controllers, so the devices become stateless. UCS, our server platform, was a good example of this. This allows even more reusability and flexibility from how we configure policy and how we build infrastructures. How we create these overlays that allow us to create these almost transparent but virtual infrastructures across domains, across geographic boundaries, and how we extend the range of these service nodes that we can implement in real time. Now, the real benefit, as I said, in this whole presentation is really to show the integration that we're doing as two companies in this partnership, how we can continue to expose these rich features and these APIs into, in this case, Cloud Platform. So I'm going to hand over to Sheng now so he can go through a little bit more on that integration with Cloud Platform.
Thanks, Phil. So Cisco Open Networking environment is just a great network infrastructure foundation for us to build cloud infrastructure. So on top of that, what we've achieved is we've integrated this Citrix Zen Server, Citrix Cloud Platform powered by Apache Cloud Stack, and Citrix Cloud Portal. And together, that creates an end-to-end cloud infrastructure solution. Of course, Cloud Platform doesn't just work with Zen Server. It works with other hypervisors as well. And top to bottom, that creates the foundation that we use to support massively scalable mobile applications. So Cisco network infrastructure is not the only network infrastructure that Citrix software works with. But we're working very, very closely with Cisco. And I think by working closely, we're creating something very, very special. We're enabling the most efficient and most scalable infrastructure. And Phil, thank you. Thank Phil. I'd like to thank all the colleagues at Cisco for sharing our vision, for helping our customers, and for supporting Citrix Zen Server and Apache Cloud Stack. And I really look forward to continuing the collaboration so that we can realize this vision.
It's an exciting time, and we're really happy to be doing this. Thanks, Sheng. I appreciate it.
Thank you.
Thank you, ladies and gentlemen.